All right, so we are going to calculate the mean, median, range, IQR, and standard deviation by hand for this data set. For the love of cheeseburger, a simple random sample of 6 students were asked, how many cheeseburgers did you eat last month? Their responses are given below. So one person ate 2, another ate 5, 6, 6, 8, and one person ate 9 cheeseburgers in the month. So first, let's calculate our measures of center. We have the mean. In this case, it would be x bar because we have a sample. So x bar is equal to, we're going to add up our x's and divide by our sample size. That's 2 plus 5 plus 6 plus 6 plus 8 plus 9 all over 6. 12, 20, 31, 36. So our mean is 6 cheeseburgers. We always want to put units on our numbers here. These are counts, so they don't really have units, but we could just call them cheeseburgers. It's a little more important when it's inches or feet or stuff like that, but whatever. Median. Median is going to be the middle number, so let's just, and this is ordered, thankfully, so let's just count to the middle. Boom, boom, boom. Even data, so it's going to be right in between those two, so that's going to be 6 cheeseburgers. And normally I would not calculate the mode, and there's my daughter. But I will here, just because it's easy, and the most frequently occurring number is 6. But again, mode is not always the most frequently occurring number. It's the peakedness of your distribution, but let's not worry about that. All right, so those are the measures of center. Thankfully, they're all exactly the same. So it wouldn't really matter which one we use, would it? Because they're all the same. However, we will have a little bit of discussion about if they're different, which one is maybe better, or which one should we use. Now spreads. So the first two are pretty easy. Range is easy. You know the formula. It's simply max minus the min. Max is 9, min is 2, so that's 7 cheeseburgers. Okay. IQR is Q3 minus Q1. So I've already cut the data set in half with my median. So look at your bottom half, top half, cut that in half. This is Q3, bottom half. Go to the middle, there's Q1. So this is simply 8 minus 5, or 3 cheeseburgers. So the entire data set spans an interval of 7, but the middle 50% of my data set spans an interval of about 3 cheeseburgers. IQR should usually, if not, almost always should be smaller than the range. Well, it'll never be bigger, but I guess you could construct a data set where they would be perhaps the same. Now standard deviation. So this is going to be S, or S of x, because it's a sample. And if we go look at the formula, it is the square root of x minus x bar squared over n minus 1. So now we get to talk a little bit about where this comes from and why this formula is what it is and what it means. So first, let's remember our x bar is equal to 6. We've done that already. I like to make this little table to help us go through this. So let's put our data sets here, our numbers. So 2, 5, 6, 6, 8, 9. So there's our data. Now, remember, standard deviation is the average distance from the mean. So if I asked you to calculate the average distance from the mean, what would you do? Well, the mean is 6, and here are my data points. So it might make sense that you would find the distance that each of these data points is away from the mean. So let's calculate x minus x bar. This is called the deviation from the mean. Deviation, distance from the mean. That's what it's called in stats. So I'm going to take 2 minus 6 to give me a negative 4, 5 minus 6 to give me a negative 1, 6 minus 6 to give me 0, 0, 8 minus 6 for 2, and 3. So if we wanted to do the average distance, we would just add these up and divide by 2. But hopefully you see that if you add these up, we got a negative 5 and a positive 5 and a couple zeros. They're going to cancel each other out. They're always going to cancel each other out because 6 is the arithmetic middle. So the negatives will always cancel the positives when you add them. So if I get 0 every time, that's not a very good measure of how spread out they are. So I don't want them to cancel each other out. So what should we do to make them not positive and negative so they cancel each other out? Most people would say at this stage we could take the absolute value. And that is, of course, a good idea. But it's not what we do. If you take the absolute value, you actually get what's called the absolute deviation. I think it's called the absolute deviation. We don't use it a whole lot, so I'm not real sure. But I think there is a quantity for that. Instead, mathematicians decided to square the deviations. Does a couple things. Well, first of all, again, BAPS, beyond AP Stats, there's some very deliberate and meaningful reasons why we want to square it. But for us, we could just kind of say that it kind of penalizes points that are a little bit further away. Negative 4 squared is 16, 1, 0, 0, 4, 9. It's just what they do. Now, let's average them out. So let's add them up. Let's take the sum of the squared deviations. So this is the squared deviations from the mean. This would be the sum of the squared deviations from the mean. 9 and 1 is 10, 20, so that's 30. And then I want to average them. And this is where things get a little bit confusing again. We should just divide by 6, right? Yeah, you're right, we kind of should. But the formula tells us divide by 6 minus 1. So we're going to divide by 5. Okay? Why? BAPS, but I'm going to explain it to you here in a little bit. So this gives us 6. But these measures are in cheeseburgers. 4 cheeseburgers, 1 cheeseburger, 2 cheeseburgers, and 3. When we square them, we're in cheeseburgers squared. When we add them, we're in cheeseburgers squared. So to get back into cheeseburgers, to get rid of those squares, we need to take the square root of everything. And that's the formula that we have for the sample standard deviation. Our calculator, square root of 6 is about 2.45. 2.45 cheeseburgers. That's how you calculate standard deviation. Good news is, you will probably never do that. Maybe one problem on your homework, but in general, we don't do this. We use our calculator to do these things, and we focus on interpreting and using them. Okay? So here are the interpretations for these things. Interpret the mean. The average number of cheeseburgers eaten by the sample is 6 cheeseburgers. Interpret the IQR. The middle 50% of the number of cheeseburgers eaten by the sample of JCS students span an interval of 3 cheeseburgers. And interpret the standard deviation. Again, star this one. The number of cheeseburgers students eat per month typically varies from the mean by 2.4 cheeseburgers, or on average varies from the mean by 2.4 cheeseburgers. All right, so let's verify how we get these on our calculator. Okay, so I'm assuming we all have this calculator. All right, so let's open up a new document. We should always start with a fresh document so we don't have any other variables or anything stored in our current document. We are going to start with the list and spreadsheet page. There are multiple ways to input data into your calculator, but the list and spreadsheet is probably the easiest. Okay, so let's click this cell up here. The top cell is going to be the name of your data set and the name of your list. So I'll call this C Berg for cheeseburgers. Seaburgs. This cell is going to be for formulas. We don't want formulas. We're just going to put in our raw data. So 2, 5, 6, 6, 8, 9. Common mistake is not to hit enter on that last data point. If you go up here and open up a new page and start doing some other calculations, this data set only has 5 data points in it. So everything you do is going to be incorrect. Please, please, please hit enter on that last data entry. Okay, so now let's do some calculations. If we want to do, by the way, these are, when you look at these as a whole, like all of these measures, those are called the summary statistics of your data set. So let's calculate the summary statistics. That is a calculation in the calculator, so control doc. Oops. And then go to calculator. And here's the command. Menu, statistics, stat calculations, one variable statistics, number of lists. So we got one list. That list is, you're going to hit like tab, or I think you can hit over, cycle over, and it'll show you what lists are in your calculator. We now just have one list, but if we had a whole bunch of lists, there might be several options. So we're just going to choose that first list, only list. Keep this at 1. Keep these 3 things, leave these things alone. We'll maybe talk about those later. Just hit OK and we're done. Okay. All right, so here's the summary statistics for this data set. So let's go through these one at a time. X bar, that is your mean. These two we don't use very much, but you can figure out what they would be. This is the sum of the x's. If you remember when we calculated the mean, we added up those 36. So we can see that here. These next two values are the standard deviation. This is the sample standard deviation. This is the population standard deviation. It even says here we're dividing by n-1 and here we're dividing by n. So this is the value that I calculated because I divided by n-1. Now when you put the data in the calculator, it doesn't know if it's sample statistics or a census. So it just gives you both and it says you can pick out whichever one you want. N is the number of data points, that were 6. Then here, these 5 numbers make up what we call the 5-number summary. We'll talk about this a little bit in a future video, probably the next one. So the 5-number summary is the min, the max, the middle, and then the middle, bottom, middle, top. So Q1 and Q3. This is the sum of the squared deviations. This was that 30 I calculated before I divided by the 5 and took the square root. That's it. And whenever you, after you've calculated this in your calculator, after you've run this calculation, if you hit the vars key, it'll actually have a whole bunch of statistics. If we would have hit the vars key before we did this, we would have only had our list in here because that's the only thing we made. But when we do the one variable statistics, it stores in all of these values. For example, what do you suppose this stat.sx is? That is the S sub x, or the sample standard deviation. What do you suppose Q3x is? It stores that. That is the 3rd quartile. Now this doesn't calculate the IQR in the range, but it gives us Q3 and Q1, so we can calculate the IQR and range pretty easily. All right? All right. Why do we use the formula? Why does the standard deviation formula have a different denominator? That's a good question for the next video. Why are these two formulas different? It's BAPS, but I'm going to explain in the next video. Now you're going to want to watch it, right? Probably not, but that's okay.